Have you ever wished you could travel somewhere super fast without having to get on an airplane? Imagine hopping on a train that looks like it zoomed right out of a science fiction movie and arriving in a different city in the time it takes to watch a film. Well, that's exactly what bullet trains do. The story of the bullet train really kicks off in Japan. Back in 1964, when Tokyo was getting ready to host the Summer Olympics, Japan unveiled the world's first high-speed rail line, the Tokaido Shinkansen. People were absolutely amazed. They called it the bullet train because of its sleek, rounded nose and its incredible speed. The Shinkansen connected the huge cities of Tokyo and Osaka, shrinking a journey that took nearly 7 hours down to just 4. Suddenly, people could commute for work or visit family in a fraction of the time. After seeing Japan's incredible success, other countries thought, hey, we want to do that too. Europe soon followed, with France's TGV. But in the 21st century, another country took high-speed rail to a whole new level: China. Why are bullet trains shaped so funny? Why do they have those long, pointy or rounded noses instead of a flat front like an old-fashioned train? The answer is all about fighting against something invisible that's all around us: the air. Think about what happens when you stick your hand out of a moving car window. If you hold your hand flat, the air pushes against it really hard. But if you turn your hand sideways, so it's thin and sleek, it cuts right through the air. To beat this invisible wall, engineers use a science called aerodynamics. Bullet train designers spend countless hours in wind tunnels, testing different shapes to find the one that lets the air flow around it as smoothly as possible. To solve this, Japanese engineers looked to nature. They noticed that a kingfisher bird can dive into water to catch a fish with barely a splash. They studied the shape of the kingfisher's beak and used that inspiration to design an even longer, more pointed nose for the train. You might be surprised to learn that the classic bullet train, like the Japanese Shinkansen, works on a principle that's been around for over a century: steel wheels on steel rails. But these aren't your grandpa's train wheels. Everything has been perfected and supercharged for high-speed travel. Unlike old trains that had a single big engine at the front pulling all the cars, modern bullet trains use something called a distributed power system. This has a few big advantages. It spreads the train's weight more evenly, which is better for the tracks. It also means the train can accelerate much more smoothly and quickly. Powering all these electric motors takes a huge amount of electricity, far more than you could get from a regular power outlet. A special arm on top of the train, called a pantograph, reaches up and slides along this wire, collecting the high-voltage electricity needed to run the motors. This is also why bullet train lines need their own dedicated power substations along the route. The final piece of the puzzle is the shape of the wheels themselves. They aren't flat, they are slightly cone-shaped. This clever design helps steer the train and keep it centered on the tracks, even as it goes around gentle curves at high speed. Just when you thought trains couldn't get any cooler, along comes a type that doesn't even have wheels. Meet the Maglev train, which stands for magnetic levitation. That's right. These trains literally float on a cushion of air, held up and pushed forward by powerful magnets. Think back to when you played with magnets as a kid. You probably noticed that if you try to push two like poles together, a north pole to a north pole or a south to a south, they push each other away. Maglev trains use this exact principle for levitation. Powerful magnets on the bottom of the train and on the top of the guideway are set up to repel each other. The guideway has another set of magnets along its walls. These magnets are electromagnets, which means we can turn them on and off and even flip their poles from north to south very quickly. By precisely timing the switching of these magnets, we can create a magnetic wave that pushes and pulls the train along the guideway. It's like the train is surfing a magnetic wave. Because there are no moving parts like wheels or engines grinding against a track, Maglev trains are incredibly smooth and quiet for the passengers inside. The Shanghai Maglev in China, which connects the city to its airport, zips along at 431 kilometers per hour. And Japan is currently building an even more advanced Maglev line, the Chuo Shinkansen, which is designed to travel at over 500 kilometers per hour. Traveling at the speed of a small airplane, but on the ground, might sound a little scary. But here's a fun fact. Bullet trains have one of the best safety records of any form of transportation in the world. This incredible record isn't due to luck. It's thanks to layers upon layers of amazing safety technology working behind the scenes. The most important system is the automatic train control, or ATC. You can think of this as a super smart computer co-pilot. The ATC system is constantly communicating with the train, telling it the maximum safe speed for the section of track it's on. If the human driver ever goes too fast or fails to slow down for a curve, the ATC will automatically apply the brakes to keep everyone safe. The ATC knows the location of every other train on the line. The track is divided into invisible electronic sections called blocks. A train is never allowed to enter a block that another train is currently in. This creates a safe, invisible bubble around each train, making collisions virtually impossible. It's one of the key reasons why bullet train travel is so remarkably safe day in and day out. Countries like Japan are also located in areas with a lot of earthquakes, which could be very dangerous for a fast-moving train. To handle this, the Shinkansen network is equipped with a sophisticated earthquake detection system. If these sensors detect the first faster-moving waves of an earthquake, called P waves, they instantly send an alert. This alert automatically cuts power to the overhead lines and triggers the emergency brakes on all trains in the affected area. Finally, safety isn't just about computers and sensors, it's also about people. The drivers of bullet trains undergo years of intensive training, including countless hours in advanced simulators. Special diagnostic trains, like Japan's famous Dr. Yellow, run along the lines regularly, using high-tech sensors to check the tracks and overhead wires for any tiny flaws or signs of wear. You can't just run a 300-kilometer-per-hour bullet train on any old set of tracks. It needs its own special, dedicated superhighway. One of the biggest secrets to the success and safety of high-speed rail is that these trains run on their own exclusive lines. There are no slow freight trains, no local commuter trains, and absolutely no road crossings. This completely eliminates the risk of collision with other vehicles, and allows the train to maintain its high speed without interruption. Building these dedicated tracks is a massive engineering project. They must be as straight and flat as possible, which often means building long tunnels through mountains and high bridges or viaducts across valleys and rivers. Unlike regular railway tracks, which are often laid on a bed of gravel called ballast, many high-speed lines use a solid concrete slab for the track bed. This provides a much more stable and durable foundation that won't shift over time. The rails themselves are often welded together into one continuous, long ribbon of steel. This gets rid of the familiar clackety-clack sound you hear on older trains, which is caused by wheels passing over the small gaps between rail sections. On a bullet train, the ride is smooth and quiet because the track is a seamless path. Powering these metal beasts is another huge challenge. A single bullet train can use as much electricity as a small town. Along the route, dedicated electrical substations are built every 20 to 50 kilometers. Finally, all of this infrastructure, the tracks, the power, and the trains themselves, is managed by a central command center. Think of it like air traffic control, but for trains. Bullet trains are more than just a thrilling ride, they are a powerful tool for building a better future. One of their biggest benefits is for our planet. When you compare them to other ways of traveling between cities, high-speed trains are incredibly energy efficient. On a per-passenger basis, taking a bullet train can produce up to 90% less carbon dioxide than flying the same route. Beyond the environmental benefits, bullet trains completely change the way people live and work. A journey that might have been a grueling 3-hour drive can become a comfortable 45-minute train ride. This allows people to live in smaller, more affordable cities or towns while still working in a major city center. It makes a country feel more like a single, connected community. The technology behind bullet trains is also constantly evolving. Engineers are always working on making them faster, lighter, more efficient, and even more comfortable. This constant innovation means that the bullet train of tomorrow will be even more amazing than the ones we have today, continuing to shrink distances and bring people closer together. In the end, bullet trains are a brilliant example of human ingenuity. They are a solution that is faster than a car, more environmentally friendly than a plane, and safer and more reliable than both. As we look to the future of transportation, these sleek, speedy machines offer a clear path forward, a path that is faster, greener, and smarter for everyone. The journey of the bullet train is far from over. It's a technology that will continue to shape our world for decades to come.